The condition for reciprocity and symmetry expressed in terms of inverse transmission parameters. The condition for reciprocity will be determinant of this a dash b dash c dash d dash will be equals to 1, and condition for symmetry will be a dash d dash. These two conditions you have to prove considering z1 considering this you will have to prove by considering connecting a voltage source first at port 1 and then short circuiting port 2 and then interchanging the position of the source and the response. You will have to arrive to this condition, and this condition can be arrived at by considering the condition of symmetry in terms of z parameter, that is z11 is equals to z22, but these things you have to prove. The method we have already discussed in case of transmission parameters, right? Next is inverse hybrid parameters, where I1 V2 will be expressed as a function of V1 I2. In hybrid parameters, V1 I2 was expressed in terms of I1 V2. Here just the reverse one, and I1 V2 will be equals to G11 G12 G21 G22, and this column this vector V1 I2. So to define these inverse hybrid parameters, two of these parameters will be defined in terms of if you consider V1 equals to 0, that is when the port 1 is short circuited, and again two parameters will be obtained. These two parameters will be obtained by considering port 2 open, that is when I2 will be equals to 0, and the values of the parameters will be like this. The condition for reciprocity will be in terms of inverse hybrid parameters will be G12 equals to minus G21, and condition for symmetry will be G11 G22 minus G12 G21 equals to 1. That is determinant of G11 G12 G21 G22 will be equals to 1. These things you have to prove, deduce. So these two things are left for your assignments, and the next class we will be doing interconnections of two-port networks, several interconnections of two-port networks, right?